Hi guys, today our agenda, important features of Apache Spark. The first feature, in-memory computation. Spark performs in-memory data processing, which means after performing each operation, it keeps data in memory rather than writing into a disk. What is an advantage? It speeds up data processing because read and write to a memory is very fast compared to a disk. Understand? Right. Distributed processing. Spark distributes the data and computation across a cluster of machines. Spark distributes data and computation across a cluster of machines. What it means? When you create an RDD or data frame, the data gets divided into partitions. These partitions are distributed across many worker nodes in the cluster. Understand? Right. What is an advantage? It can efficiently process large data sets in parallel. Understand? Right. DAG execution model. It optimizes the execution plan by chaining all the transformations in a more efficient manner. What is an advantage? It improves the performance with an efficient distributed processing. It improves the performance with an efficient distributed processing. Understand? Right. Data caching. Spark allows user to cache intermediate data in memory. It means the frequently accessed data can be stored in memory for quick retrieval. The data frame or RDD, if you use frequently, then you can cache the data set in a memory. You can store the data set in a memory. For what? For retrieval, for quick retrieval. For quick retrieval. What is an advantage? It eliminates the need to recompute the same data repeatedly. Understand? Right. The next feature, lazy evaluation. Spark uses lazy evaluation, meaning it doesn't execute transformations immediately. Whenever you apply transformation on an RDD or data frame, Spark doesn't execute immediately. Instead, it builds a logical execution plan. That means lineage. Whenever you perform an action, then only the transformation gets executed. Understand? Right. What is an advantage? It optimizes the execution plan by eliminating the unnecessary computations. Next feature. Inbuilt optimizations when using data frames. Spark provides several inbuilt optimizations when working with data frames. One of the inbuilt optimization, catalyst optimizer. What it does? It transforms a logical query plans into a efficient physical execution plans. Therefore, what is an advantage? It improves the performance. Understand? Right. Immutable. When you apply any transformation to an RDD or data frame, it doesn't affect the original RDD. It creates a new RDD. What is an advantage? It plays a crucial role in Spark fault tolerant mechanism. It plays a crucial role in Spark's fault tolerance mechanism. Right. Next, fault tolerant. Before talking on fault tolerant, first discuss on lineage. When a transformation is applied to an RDD or data frame, we know that Spark doesn't execute the transformation immediately. Instead, it records the transformation as a lineage. We generally call it builds logical execution plan. When a transformation is applied to an RDD or data frame, Spark doesn't execute immediately. Instead, it records the transformation as a lineage. That means it builds logical execution plan. Okay. So where this lineage is helpful. If any partition of data is lost due to a node failure, if a partition of data is lost due to a node failure, Spark can use the lineage information to recompute that partition from the original data source and apply the recorded transformations to regenerate the lost data. Understand? Right. The lineage is very helpful in fault tolerance mechanism. Now you have one question. What if the original data source is modified? We discussed that it is immutable. When you apply any transformation on RDD or data frame, it doesn't affect the original one. It returns a new one. Understand? Right. The next feature is supports SQL. It allows SQL queries to run on data frames. Advantage? It makes developers job easy. Since most people are familiar with SQL, they feel processing data using SQL is very easy. Understand? Right.